Okay, so let's find an equation for this sine wave here. Okay, and so in this problem, I would tell you that this is a sine wave and not a cosine wave, for example. Okay, and the first thing that I notice here is, well, I don't really see the usual sine wave shape, which is that it goes up and then down like that, right? Instead, I see that it goes down and then up like that. And so this is going to be an upside down sine wave, which is fine. Okay, so I'm going to go ahead and highlight the part of this that is the sine wave. Yeah, just kind of trace along it just so we can look at it together. Okay, good. Okay. So it starts on the axis of symmetry, goes down and then up and then back down to the axis of symmetry. So I'm just going to label this as an upside down sine wave. Okay, now I'm going to start talking about some of the key features of the graph here, right? Let's start with the vertical shift. So the vertical shift is always going to be the distance between the x-axis, which is supposed to be the axis of symmetry, right? And where your new axis of symmetry is, right? So if your axis of symmetry is not on the x-axis itself, it must have been shifted vertically is the argument there. So the vertical shift here would be 2. Okay. Now let's look at the amplitude. And so the amplitude, that is defined to be the distance between either the smallest y value on the graph and the axis of symmetry or the largest y value on the graph and the axis of symmetry. So you could measure amplitude here if you want to, right? Or you could measure amplitude here. All right, I guess I'll do it right here though. So my amplitude will be equal to, well, let's see, this is a y value of 2. This has a y value of 0.5, so we get 1.5, right? Or I'll write it as 3/2. Okay, so that's my amplitude there. Okay, just write it as a simplified fraction. All right, now let's do my horizontal shift. Okay, so the horizontal shift is where your sine wave starts, right? It's supposed to start on the y-axis itself, but now we see that it has been shifted this many units to the right. So my horizontal shift there, since it's a shift to the right, is a positive shift of 0.5, which I'm going to express as a simplified fraction here. So that's 1/2. Okay. And then now that I have that, now the very last thing is the period, right? So the period of a sine wave is the length of the sine wave, right? So we're starting here at 0.5, right? And we're going all the way up to here, which is 8.5, right? And that's one full period right there. So let me go ahead and draw a nice little arrow from here to here. And this is the period, which is clearly 8 units. Okay. So now that I have those things from just observations from the graph, now we have to find out what A, B, C, and D are so that we get the equation of the graph is y equals A times sine of bx minus c plus d. Okay. And so we have these formulas that relate the A, B, C, and D to these features on the graph. We'll start with amplitude. Now, amplitude is always the absolute value of A, right? And in our case, this is an upside down sine wave. So then that would be negative A. Okay, so negative A is going to be equal to the amplitude that we just found, which is 3/2. So that means that my A must be negative 3/2. Okay, that was pretty painless there. All right, so we got negative 3/2. Okay, now let's do my D here. So the vertical shift is always equal to D. Right? Whatever your D is, right? So we found that it was a vertical shift of 2. So now I have D equals 2. Okay. Next, we'll do period, right? And I keep forgetting to write that T is the same thing as period. So I'm going to use T here. Okay. And for a sine wave, the period is always 2 pi divided by whatever B is, right? Assuming that your B is positive. Okay. So 2 pi over B, right, will be equal to what we found for the period here, which was 8. And then now we got to solve for b. So we're going to multiply by b on both sides here, and we'll get that 2 pi is equal to 8b, which means that divide by 8, and we get that b is equal to pi divided by 4. Okay, so there we have it. And then now we'll do our horizontal shift. Horizontal shift is always equal to c divided by b, again, assuming that b is positive, right? So horizontal shift equals c over b. Okay, and we already know what b is. We'll keep that in mind in just a second. But my horizontal shift is 1/2. All right, so I can cross multiply here, right? Multiply by 2 on both sides, and we'll get 2c. Multiply by b on both sides, and we get that 2c is equal to b, right? We could do that. Probably just be easier, though, to just leave the 1/2 on the right-hand side and multiply by b. So we get c is equal to b divided by 2, right? But we know that b is pi over 4, so c is equal to pi over 4 divided by 2, which would be pi divided by 8. Okay? So now we found our a, b, c, and d, so now we just have to plug it into the formula here. We get y is equal to -3/2 sine of our b is pi over 4 times x. Our c is pi over 8. Don't forget this minus sign belongs in there, though. So minus our positive pi over 8 here, and then plus d, which is 2. So that is an equation that will give us this graph over here. And of course, there are infinitely many correct answers, right? Depending on where you start your sine wave, right? In this case, there was really only one place to start it, which was right here. Okay. Okay. So, um, maybe in the same video, right? Well, let's try treating this as a cosine wave instead of a sine wave. Because remember that there's really no difference between a sine wave and a cosine wave. So let's see if we can find an equation for cosine instead. So here's the exact same graph that I had before. Okay, and we want to think about this as a cosine wave. Okay, now a cosine wave starts at its maximum value, then goes down and then back up to its maximum value. So that's the shape of a cosine wave. So when we draw our cosine wave on here, right, it's going to start at its maximum y value. It's going to go down past its axis of symmetry, down to its minimum y value here. Okay, and then it's going to turn around and start going back up, back to its maximum value. Okay, and that is one full period of cosine. Okay, so now that we have that, right, we can go ahead and start talking about some of these parameters. Okay, so the horizontal shift, well, let's do the horizontal shift last. Let's do the vertical shift first. Okay, the vertical shift is again just this distance between your axis of symmetry and the x-axis, right? So the vertical shift is still 2 units, okay, just like it was for the sine wave. Okay. The amplitude is still the distance between the maximum y value and the axis of symmetry, right? So that's an amplitude of 1 whole unit and then half a unit, so 3/2 units. Okay. The period, right? Well, it goes from maximum to maximum, right? So that's here at -3/2 all the way up to 6.5, right? And so our period here is going to be make that arrow there, that distance, t, which is equal to, well, that's 6.5, right? So I'm going to write that as 13/2, right? Minus -3/2, right? Okay, so just subtracting those two x coordinates to find the distance there, right? And so that's going to be a 13/2 plus a 3/2, which of course is 16/2, which is still 8, right? So you could do it that way, or you could do it this way, right? Just starting here, right? It's half a unit to get to -1, and then another whole unit. So that's 1.5 units, 2.5 units, 3.5 units, 4.5 units, 5.5 units, 6.5 units, 7.5 units, and then another half unit makes 8 whole units, right? So that's our period there. Okay, now let's do our horizontal shift, right? And our horizontal shift is the distance between the place where our cosine wave starts and the and the y-axis, right? So this distance right over here. So from, I'll put it right here, from here, this distance all the way to here, right? So that distance between here and here would be, well, let's see, -3/2, right? So our horizontal shift, because it's a shift to the left, we have that's -3/2. Oh, I should probably write it down here. -3/2. There we go. And then now the formulas to actually get the A, B, and C, and D, and everything. So those are actually all the same as they were for sine. So for instance, the amplitude is still the absolute value of A. Okay, but here this is a right side up cosine wave, right? If it was upside down, it would look like this instead, right? Okay, so this is a right side up cosine wave, which means our A is positive. So we get A is equal to 3/2. Our vertical shift, right? Well, that's always equal to D. And our vertical shift was equal to 2. We saw that on the graph. So we get D equals 2. Okay. Our period is 8. right? But our period is always equal to 2 pi divided by b when we're talking about a sine wave or a cosine wave. And here we're assuming b is positive, right? So we get 2 pi over b is equal to 8 because we have to solve for b, but we're going to get the same thing as last time. We get that b is equal to pi over 4. And that's because, well, this sine wave is really, I mean, this cosine wave is really just a sine wave that's been shifted. So the period is still the same, okay? So then our b will still be the same as well. And then now we'll do horizontal shift, which is C over B, right? And that's equal to 1/2, right? Oh, sorry, no, our horizontal shift is different now. Now it's -3/2. Okay. All right. So then now we got to solve for B. So then we get that C is equal to -3b over 2, just multiplying by b on both sides. But now we remember that b is pi over 4. So this is going to turn into a -3 times pi over 4 divided by 2. Okay, so that would be a -3 pi over 8, like so. Okay, and then we can't reduce that any, so that's going to be our c then. So now we have y is equal to 3/2 times cosine of my b is pi over 4 times x minus -3 pi over 8. So that's going to turn into plus 3 pi over 8 then, give us minus c, right? Plus d, and our d is 2. All right, there we have it.